Hello everyone and welcome to today's lesson. I'm Mrs Jennison and I'm an Associate Director for Outward Grange Academies Trust, and today we will be learning about investigating burning. Now before we start, it would be really useful if you turned off your notifications so that you didn't get distracted during this lesson. It would also be really useful if you had a pen and a piece of paper. And in today's lesson, it would also be great if you had access to a calculator. Now this is a lesson in our Saving Planet Earth topic. Previously, we have looked at what is the structure of our Earth and beyond, and today we are continuing our work on what fuels need to burn. Following this, we will start to look at how we can be more fire safe. Our challenge today is to be able to describe the conditions needed for fire. Our aspire is to be able to explain using data how changing the amount of oxygen will affect burning. Now, our previous lesson we looked at what causes fire and we looked at the fire triangle. For fire to burn, those three components are required: heat, fuel and oxygen. And if you take away any one of those things, the fire will no longer burn. Now the chemical name for the reaction occurring during burning is combustion, and it can be summarised by the word equation: fuel plus oxygen forms carbon dioxide and water. Now in today's lesson we will be investigating the effect of changing the volume of oxygen on fire. To do this we will be changing the sizes of various beakers and placing them over a candle to see how long it takes for the flame to go out or extinguish. Now how can we carry out this investigation? We will need beakers of different sizes, a candle and a stopwatch. We can light the candle, place the smallest beaker over the top and time how long it takes to extinguish. We can then repeat that 3 times and calculate a mean, and repeat for each different size of beaker. Now, I'd like you to identify from our investigation and what we've gone through so far, what will be the independent variable. That's the variable we are going to change. What will be our dependent variable? This is what we are going to measure. And what will our control variables be? What will we need to keep the same? So our independent variable will be the size of the beaker. Our dependent variable will be how long it takes for the flame to extinguish. And our control variables will be it's the same fuel. We need to make sure that we are using the same fuel each time. And the same material that the beaker is made from, as some may be more porous than others. Now I'd like you to write a method for our investigation. I've placed some of the images on the screen from earlier on to support you with writing that method. I'm just going to give you a little bit of time to complete that task. So you should have something like needing a range of beakers of different sizes, a candle and a stopwatch as your equipment. You will light your candle, place the smallest beaker over the top and time how long it takes for the flame to go out or extinguish. Then repeat this 3 times and calculate a mean, and repeat for each different size of beaker. Now I've provided you with a table for your results, so it would be really useful if you need this to pause and really quickly copy this down, as I will insert here a recording of this practical for you to collect some results from. This is an investigation to show how changing the amount of oxygen will affect the length of time a fuel will burn for. Now in this investigation I've got a range of different sized beakers. These are going to be placed over a candle and we will time how long it takes for the flame to extinguish. Now in our beakers we do have these lips that are for pouring, so to make sure that this investigation is carried out fairly and there is no additional oxygen getting into the beaker, we are going to block off those lips so that there's no external air getting in to the flame. So now it's time to carry out our first investigation. The first beaker we are going to use is the largest beaker we have today, which is a 500 milliliter beaker. I'm going to place this over that candle and time how long it takes for the candle to extinguish. So, and that took 17.34 seconds. So now I'm going to repeat that 3 times so that I'll be able to calculate a mean, and I'll show you those repeat readings when we go back to the PowerPoint and I go back to the lesson. So the next beaker we will use is a 400 milliliter beaker. So I'm going to place that over now, and I'm going to start my stopwatch. So and that took 14.44 seconds. I'm going to repeat this 3 times so that we can calculate a mean, and I'll provide you with those results soon. Our next measurement will be for a 250 centimetres cubed or millilitres beaker. So again, I'm just going to place that over the candle and time how long it takes for the flame to extinguish. And that took 9.12 seconds. So now it's time for our 100 milliliter beaker. And that took 3.66 seconds. And our final beaker, which is the smallest of our range of sizes, is our 50 milliliter beaker. So let's place that over the candle and time how long it takes for the flame to extinguish, and it was 1.25 seconds. So as I've already said, all of these measurements will be repeated so that we can calculate a mean and check for any anomalous results. But we can see a general pattern from our first set of results that as you decrease the size of the beaker, the candle extinguishes quicker. And that's because there's less air in that beaker to fuel that fire, to provide the oxygen for that combustion. Therefore, it will run out of oxygen quicker, and therefore the flame will be extinguished. So here are some example results. Now you can see we have the size of the beaker. Now I have written words, and yes, I have placed the volume of that beaker next to it in brackets. However, that is not necessarily the volume inside the entirety of the beaker, especially because we made adjustments to ensure that there was no gaps between the lip of the beaker and the surface. So for our graph, we are just going to use the labels as the sizes of the beakers, and we are not going to use numbers because they are not accurate. They are not the exact volume inside of that beaker. Now, we will need to calculate a mean. So what I'm going to do is I'm going to work through the smallest beaker's mean. Now you may remember from maths that to calculate a mean, you add up the 3 values and then you divide by 3. So in this case, that would be 1.25 add 1.19 add 1.23, which equals 3.67, which gives us 3.67 divided by 3, and that answer is 1.2233333333. However, our stopwatch only measured to 2 decimal places. Therefore, our mean should only be given to 2 decimal places. Now, there was no anomalous results in these 3 repeats, but if you do get any anomalies, do not include them in your mean. There is one in the table. You would then just calculate the mean of the other 2 measurements. So I'm going to give you some time now to calculate those means. So you should have the means seen on the screen now. Now the only issue may have been if you did not discard the anomalous result for the third measurement of the large beaker. If you had included that, you would have had a much higher mean. However, it was much higher than the other two values, therefore I didn't include it because it was anomalous. Now, which kind of graph will you draw for your results? And I'd like you to explain your answer. Now, the type of graph we will draw is a bar chart. Now that is going to be the most suitable as the size of beaker, our independent variable, is categoric. Were we to use the volumes of the beaker, then that would have been a scatter graph with a line of best fit. However, these weren't measured and weren't accurate because we were adapting the beaker to close the seals. So it is a categoric variable, which means it is a label and it will fit into a bar chart more appropriate. A continuous variable would suggest a scatter graph with a line of best fit, and a continuous variable is a variable that can take a number that can take any value. So now you may wish to pause and complete your graph. If you struggle with graphs, then there is a video that will be playing after this slide to show you how to construct your graph. If you want to have a go at it first, then remember that your independent variable will always go on your x-axis and your dependent variable will go on your y-axis. So if you'd like to have a go at it yourself, pause now and draw your graph. But if you're unsure, please resume the video and there is a model worked example coming up. So let's show you how you can set up your graph for your results. The first thing we will need to do is we need our axes. So I'm going to draw our axes onto my graph. Now on our x-axis, we always place our independent variable. And in this case, it was the size of the beaker. Now, we didn't take a value for the size of the beaker. Yes, the beakers had different volumes that they could measure, but that's not actually the size of the inside of the entirety of that beaker. So we are just going to classify them with labels. So we had 5 sizes of beaker. We had the smallest, then we had the small beaker, then we had the medium beaker, then we had the large beaker, and then we had the largest beaker. So, smallest, small, medium, large, and largest. So there we have our labels for our x-axis. The next thing we need is we need to label our y-axis and decide on an appropriate scale. Now the largest measurement we have on average was 17.81 seconds. So that means our scale needs to go up to at least 18 and possibly 19 or 20 so that we've got that little bit of extra so we can show the pattern of our results and just make it a more suitable scale. So first thing I'm going to do is I'm going to label it. So this is the time taken for the flame to extinguish. And that is measured in seconds. So if we check these first, I think that because of our scale being quite large, we could possibly go up in ones. So let's just check 1, 2, 3, 4, 14, 18, 19, 20. So we can definitely go up in ones. And in between each digit, so in between 0 and 1, I've got 10 very small little boxes. So I'll be able to plot to 1 decimal place. Now, yes, our results are to 2 decimal places because that's what the stopwatch could measure. That's our resolution. So we are going to have to just plot this as closely as we can. So let's get this all set up. Okay, so if we put our first bar, the smallest beaker extinguished in 1.22 seconds. So that would be 1.2, so 2 little squares above 1 second. So if I just draw my line there, as you can see, I am using a ruler for the height of my bars. That's so that I don't get a slant or a wobbly top to the bar. I want it to be very, very neat. I'm also using a mechanical pencil. This is not a pen, it's a mechanical pencil. So if I make any mistakes, I can rub them straight out. So for our small beaker, like for example, I've just realised I didn't make my bar wide enough. So I'm just going to rub out that line there. So before I plot the small beaker, I just need to extend my smallest beaker. That's why it's really important we draw these in pencil. So now I can plot my small beaker. So my small beaker's average was 3.63. So if I go up to 3, and that's going to be 6 little boxes above 3, 1, 6, that's there. Remembering that each of my bars is 2 boxes wide this time. And there's my bar for my small beaker. So now let's have a look at the medium one, which is 9.24. So 9.2. Just a little bit above 9.2. If I draw a line across, again remembering each of my bars is 2 squares wide, and then extend that down. So when you're putting these, it's really important that you use that ruler to make sure the top of your bar is flat and straight. So our next one is the large beaker. So the large beaker has a mean of 14.40. So if I go up to 14, and it's going to be 14's here, so then I need 4 little squares above 14, which is there. Use a ruler to follow that line across, and then extend my bar down. Always following that line, really neat and really tidy. Okay, and then our last one was 17.81, so I'm going to plot it at 17.8. So if I count 1, 2, 3, 4, 5, 6, 7, 8. You can also check that because it's 2 little boxes down from 18. And then follow that line across. Follow that all the way down that line. So I've got my largest speakers bar. And there we have it. That's my bar chart to show how the different size beakers, the flames extinguished in different times. So now it's time to start to complete a conclusion from our investigation. When you are doing this, it would be really useful to have either your table or your graph handy so that you can quote some example results in your conclusion. I have some example sentence starters to support you with your conclusion. So you may want to say that the candle went out the quickest in and suggest which beaker. It took X seconds. So then you're quoting the time and then whereas. So then you could put the opposite side of that. So you could say where the candle went out the slowest and how long that took. And then to explain your reasonings behind those values, why did that candle stay lit longer in the other sized beaker? And I'll give you some time to complete your conclusion. Answer for you to compare yours against. The first part of the answer is the pattern. So as you increase the size of the beaker, the candle stayed lit for longer. Then some evidence. I found that the candle went out quickest in the smallest beaker. It took 1.22 seconds, whereas the largest beaker extinguished in 17.81 seconds. That's where we are supporting that pattern. And then an explanation. This is because the largest beaker had the most air trapped around the flame, therefore more oxygen, so it could burn for longer. Now that's everything from me this lesson, and I will see you soon.